Now let's take a look at the end behavior of the reciprocal function. As the values of x approach infinity, the function values approach 0. As the values of x approach negative infinity, the function values approach 0. And symbolically, we can use the arrow notation. So if we take a look at x is approaching positive infinity, what happens to the function? It's approaching 0. So that is right here. As x is going towards positive infinity, okay, what's happening is that the function is approaching 0. It's getting close to 0 on the x-axis. Okay, and as x is approaching negative infinity, the function is approaching 0. So that's over here. So as x is approaching negative infinity, we can see that the function is approaching 0. Now, based on this overall behavior in the graph, we can see that the function approaches 0, but never actually reaches 0. It seems to level off as the inputs become large. This behavior creates a horizontal asymptote, a horizontal line that the graph approaches as the input increases or decreases without bound. In this case, the graph is approaching the horizontal line y equals 0. So let's go ahead and put in that. So you can see here that there is a line here where it's not going to cross the x-axis, and that is considered the horizontal asymptote at y equals 0. And then you can see here that here is our horizontal asymptote. And recall that we've already discussed the fact that we have a vertical asymptote at x equals 0. So a horizontal asymptote of a graph is a horizontal line, y equals b, where the graph approaches a line as the inputs increase or decrease without bound. We write as x approaches positive infinity, or as x approaches negative infinity, the function is approaching the value of b.